Hi all, in this video we're gonna talk about solving first order differential equation, separable method, and we will solve these 4 different examples. If you are new to differential equations, kindly watch the previous video. You will find it in the comments section. And now let's start. First order differential equation is an equation that relates a variable y with its first derivative y prime. And of course we will have some terms, for example x or e to power x, and some constants, so plus 5. So this is the first order differential equation. We have 6 methods to solve these types of equations. The first one is separable method that we're gonna talk about it in this video. Homogeneous, non-homogeneous, linear, Bernoulli, and exact differential equation. And depending on the differential equation that we have, we will choose the suitable method to use. And now let's talk about separable method and take some examples. Separable method is summarized by separating dy and dx. So if you have an equal sign here, we should have dy on one side and dx on the other side. Beside dy, we should put all the expressions containing y, for example, y plus cosine y plus 3y squared, whatever. And beside dx, we should have all the expressions containing x. So x cubed minus tangent x plus e to power x, whatever. Let's try to do that in this equation. First, we have to separate dy and dx. So if you multiply by dx both sides, we will get dx, remove dx, and here we have x squared plus 1 dy equal to xy dx. Now we have this y term beside dx, so we should remove it. Just divide both sides by y. We will get y, remove y, and here we have x dx, and on the first side we have x squared plus 1 divided by y dy, and on this side we have x squared plus 1 beside dy, so we should remove it. So just divide by x squared plus 1. So here x squared plus 1, and here x squared plus 1. These two eliminate each other. We have 1 over y dy equal to x over x squared plus 1 dx. Now we reach this shape. We have dy and all y terms, and dx and all x terms. The final step is to integrate both sides. So we will integrate 1 over y dy and x over x squared plus 1 dx. Integral for 1 over y dy equal to ln absolute value of y. What about this one? We know that integral for u prime over u dx equal to ln absolute value of u plus c. So suppose that u equal to x squared plus 1, then u prime will be 2x. So we should have 2 in the numerator, and we should divide by 2 like that. Now we have the shape u prime over u. Its integral is ln absolute value of u, which is x squared plus 1. I won't write absolute value because it's positive, plus c. Now we have to find y, just exponentiate both sides. So absolute value of y equal to e to power 1 over 2 ln x squared plus 1 can be written as ln x squared plus 1 to power 1 over 2 plus c. E and ln cancel each other, so we will get x squared plus 1, and 1 over 2 is square root multiplied by e to power c. Another example, dy by dx equal e to power x minus y. So the first step is to separate dy and dx. So we have to move dx to the other side of the equation, multiply both sides by dx. We will get dy equal e to power x minus y dx. Now we have to remove this y to the other side. We know that e to power x minus y equal e to power x divided by e to power y multiplied by dx. To remove this ey to the other side, multiply both sides by ey. Now we will get e to power y dy equal e to power x dx, and the final step is to integrate both sides. Integral for e to power y equal e to power y, and integral for e to power x equal e to power x plus c. To find y, we will ln both sides, so ln for e to power y equal to ln the absolute value of the other side. So here y equal to ln absolute value for e to power x plus c. Another example. In this example, we do not have dy by dx, but we know that y prime is equal to dy by dx. So 3 cosine x times dy by dx equal to sine x. Now we have to separate dy and dx. So if we multiply by dx both sides, we will get 3 cosine x multiplied by dy equal to sine x dx. Now here we have a y term dy and a term containing x, so we should remove it. If we divide by cosine x both sides, so 3 dy equal to sine x over cosine x equal to tangent x dx. And the final step is to integrate both sides, so integral for 3 dy equal to integral for tangent x dx. 3y equal integral for tangent x equal to ln absolute secant x plus c. So finally y equal to ln absolute secant x plus c divided by 3. And the final example. So first of all, we have to separate dy and dx. If we multiply both sides by dx, so we have x cubed y dx and dx, so dy equal 1 plus x times secant 3y dx. Now we have here dy and a term contain x, so we should divide by x cubed to remove it. So y dy equal to 1 plus x over x cubed secant 3y dx. Here we have dx and a term contain y, so we have to remove it also. So divide by secant 3y both sides. So we will get y over secant 3y dy equal to 1 plus x over x cubed dx. And we know that secant y equal to 1 over cosine y. So secant 3y equal to 1 over cosine 3y. Here we have 1 over secant 3y. So 1 over secant 3y is equal to cosine 3y. So instead of y over secant 3y, we can write y times cosine 3y dy equal to 1 plus x over x cubed dx. And the final step is to integrate both sides. So integral for y cosine 3y dy equal integral for 1 plus x over x cubed dx. Now integral for y cosine y, I will try to do it using tabular integration. So here we have derivative and integral. Just put y here and cosine 3y here. You can watch the video about tabular integration in the channel list. So derivative of y equal to 1, derivative of 1 equal to 0. We reached 0, so we will stop. And integral for cosine 3y equal to sine 3y over 3. Integrated another time, so minus cosine 3y over 9. Now multiply y times sine 3y over 3 and 1 times 1. The first one should be multiplied by a positive sign and the second one by a negative. So y times sine 3y over 3 equal to y sine 3y over 3 minus and minus, so plus 1 times cosine 3y, so cosine 3y over 9 equal integral for 1 over x cubed. 1 over x cubed can be written as 1 over x cubed plus x over x cubed, which is 1 over x squared, and dx both sides. This one is equal to x minus 3 dx, and this one x minus 2 dx. Integral for x minus 3 equal to x minus 3 plus 1, which is minus 2, over minus 2, plus integral for x minus 2, x minus 2 plus 1, which is minus 1, over minus 1. So we will have minus 1 over 2x squared minus 1 over x plus c. So this is the final relation. Y sine 3y over 3 plus cosine 3y over 9 equal to etc. If you like the video, please hit the like and subscribe button. And in the upcoming videos, we will talk about other methods to solve the first order differential equation. Goodbye.